This video, we're going to look at adding and subtracting radical expressions. So we're going to have an expression here. Some of these terms are being square rooted. So what we're going to need to do is put them into simplest radical form, so that way we can combine the like terms. Radicals, very similar to variable terms, can only combine with like radicals. So for example, as it is here, the square root of 12 can't combine with a square root of 3 because the radical is not the same. Similar to x cannot be combined with x squared because they're not like terms. But unlike the x and x squared, we can actually manipulate our radicals to create like terms as long as we put them in simplest radical form. So step one here, I'm just going to rearrange this with the commutative property. I'm going to put the numbers together, and I'm going to put the radical terms together. So I'm going to have 4 plus 6 plus root 12 minus 5 root 3. All right, so now everything's put in order. I'll have my numbers first, my radical terms second. From here, what I'm going to do is also, in addition to combining the 4 and the 6, I'm going to split the square root of 12 into root 4 and root 3. So 4 plus 6 gives me 10, but this 12 I'm going to break down into root 4 times root 3. And now we can see this, the startings of creating like radicals. We have a root 3 here and a root 3 here. The square root of 4, we can evaluate that. It's perfect. It's 2. And now once we have 2 root 3 and minus 5 root 3, this is like 2x minus 5x. If you had 2x, take away 5x, that would leave you with negative 3x. So here we'll have 10 minus 3 radical 3. Okay, so once we get these radicals to be the same, root 3 and root 3, we can do the math with their coefficients. So 2 minus 5 is negative 3. In example 2 here, we have quantities. So the only trick here is we got to remember to distribute that negative in and rewrite this entire line without the parentheses. So I'll have 5 plus root 32 minus 3 minus 2 root 8. Notice this minus right here. That's the tricky one. Okay, and take another step to rearrange this with the commutative property. And now I will simplify the radicals. 5 minus 3 is 2. Put this into root 16 root 2 minus 2 times root 4 root 2. Now we can see the matching root 2's. 2 plus 4 root 2 minus 2 times 2 root 2. We have to do a little combination here with the 2 times the 2. So plus 4 root 2 minus 4 root 2. And actually they cancel out, right? We have positive 4 square root 2 minus 4 square root 2, opposite signs. So the answer here is just 2. All right, so give 3 and 4 a try. Pause the video here, see if you can do them, and stay tuned for the solutions. All right, so let's take a look. Step 1, I'm going to group the numbers together and the square root terms together. Here I need to find perfect squares that multiply to 54 and to 96. Remember, we have our trick with the calculator. We can go to the y equals screen, put in 54 divided by x, head over to the table, and I'm scrolling through this list looking for a perfect square. So once I get here, I get 6 and 9. 9 is a perfect square. 7 minus 4 is 3. And a good trick to this is once you get the number that's not the perfect square for the first term, it's a good idea to check that term with the other one. So we can do 96 divided by 6, give us 16, which is a perfect square. So 5 root 16 root 6. 3 plus 3 root 6 minus 5 times 4 root 6. Root 9 is 3. Square root of 16 is 4. Now I need to multiply the 5 and the 4. 5 times 4 is 20. Finally, I have radicals that are like radicals, so I may combine their coefficients. 3 minus 20 is negative 17, so I'll have 3 minus 17 root 6. All right, for number 4, I have some distribution to do. I'll drop the parentheses on the first quantity. 2 times 2 is negative 2. 2 times positive 2 root 147 is negative 2 root 147. 75 I can split into 25 and 3. And 147, that's a pretty big number. So again, y equals screen 147 divided by x. Go to the table, and we can see a 49 here. 49 times 3. 49 is a perfect square. Square root of 49 is 7. So I have 7 plus 5 root 3 minus 2 minus 2, times 7 root 3. 2 times 7 is 14. Notice in this example I skipped using the commutative property to reorganize my line. That's not always a necessary step, as long as in the end it's standard to keep your numbers in the front and then your square root terms second. So 7 minus 2 will be 5, and then we have a positive 5 and a negative 14. That'll give me a negative 9 root 3, and now I can combine these because they're both radical 3. So there we go.